Okay, now we have the blender running, and this is the way you want it to look when it's running and you're, after you've ran for a little bit and your extruder, everything's nice and steady. You'll see it says steady system. And you'll notice on each hopper it has a little green indicator on the bottom. That means each individual feeder has reached its steady rate. To explain this a little bit, we're gonna go under the FIFO diagnostics. And this is what we talked about a little bit before. Under FIFO data, you're gonna see where we're sampling and introducing it to the first in, first out table. This is your pounds per RPM number, and this is your percent difference at the bottom of the page. This percent difference has to be within the allowed deviation to give you a steady flag for the system. So if any one of the feeders is out of steady, it will cause the whole system to go out of steady, and it'll go back to a fixed rate mode until that hopper comes back into steady. So one of the reasons we do this is if somebody leans against the hopper or shakes it, it's not going to affect the throughput unless that sample, the whole entire sample's bad. So you can see I'm sitting here moving on the way hopper and it's not changing the speed at all. So but it is a good thing. So if for some reason something happens and you run out of material or an auger fails, you'll get an indication. So once, and you see here, number 3, that's the one we're shaking. It went out of steady. It just jumped into out of gravimetric mode until it sees good samples again. And it dropped the complete blender out of steady. But we're still running a nice solid rate. So if we look at your feeder diagnostics, you'll be able to see now that feeder 3, the percent difference went up to 69.2, and it won't allow corrections by weight until it sees another steady value. So you can see the values are changing as it goes through. So we'll wait and let it clear out and show you what it looks like when it goes back to steady. So you can see now the bad samples are dropping out. We're down to 31% deviation. And we're back to 7.2%, and that feeder's back to steady. So if we go back to the main screen, we'll see all our feeders are in steady. The mass flow's in steady. We just have to wait for the steady flag from the mass flow for a steady system. And now we're back to steady system. So if you're running material, like if you're running a lot of regrind through one of your hoppers and you're never getting a steady flag, things to look at, you can go to your FIFO diagnostics, under feeder diagnostics, look how far off your percent deviation is, look at your samples. Some things you can do, if you go under your advanced settings and under your advanced hopper setup, you can make some adjustments here to damper out the variation. So regrind varies a lot as it flows. You know, you might not have consistent particle size. So what you can do is increase the feed factor filters. So we could take this up to 10. And when we do our averaging over 10 samples instead of 5, it'll dampen out a lot of that variation. The other thing you can do is increase your learn percentage. So the bigger sample you take, the less variation you're going to have sample to sample. And so you can see when we change that number of samples, we went out of steady, and it'll stay out of steady until we fill the whole first in, first out table with your 10 samples. So now to start or to stop the blender, same thing as starting it. You just hit stop here, and all the augers will stop running. And that concludes our training. If you have any questions or you have issues with your blender, you can always feel free to call the ACS service department.